Hello, this is Chris, and we are taking a look at questions 11 and 12 from section 3 of SAT Practice Test 2. So for number 11, it says, which of the following complex numbers is equivalent to 3 minus 5i over 8 plus 2i? And they offer this note that I is equal to the square root of negative 1. Now for what it's worth, by offering that note, I think instinctively a lot of people want to plug in square root of negative 1 in place of I everywhere that they see it. And that actually makes these kinds of questions unnecessarily complicated. So a good recommendation, what's worth memorizing, and the reason that they tell you that I equals the square root of negative 1 is because you do sometimes need this piece of information, which is that I squared is equal to negative 1. And I highly recommend just memorizing this on its own and not worrying about that square root of negative 1. And you'll see how memorizing this piece of information is actually going to help simplify this problem as we get into it. So whenever you're dealing with complex numbers, whenever you see I, what's important for us to understand skill-wise is that in order to get rid of I in your denominator, and you can see none of the denominators here have i's in them. There are some i's in the numerators, but we're not allowed to have an I in a denominator, just like we're not allowed to have roots in a denominator. We have to do a little bit of manipulation in order to get rid of those. So let's see how that's going to work here with I. And we're going to do something called multiply by the conjugate. So you're going to rewrite your original statement, 3 minus 5i over 8 plus 2i. And the conjugate will be whatever you have in your denominator with the opposite math function. If you're adding, the conjugate will be subtraction. So when you multiply, we always have to multiply the top and the bottom by the same thing in order to maintain the value of the fraction. So we'll multiply by 8 minus 2i on top and 8 minus 2i on bottom. And you'll see what this does, because this is actually going to work out just like a difference of squares, and when you FOIL it out, you're going to ultimately eliminate your I terms in that denominator. So let's try and FOIL this, and we'll see how that works here. So in my numerator, I have 3 times 8, which is 24. For my first terms, my outside terms, negative 2i times 3 would be minus 6i. My inside terms, negative 5i times 8 would be minus 40i. And then my last terms, negative 5i times negative 2i, will be a positive 10i squared. We'll clean that up in a little bit. Now, in my denominator, I have 8 plus 2i times 8 minus 2i. 8 times 8 is 64. And then by multiplying by the conjugate, you'll see what happens here. When you do your outside and inside terms, they will cancel out. So we're getting rid of those i's, which is helpful, and then we'll have minus 4i squared. Now remember what we said as our key piece of information to memorize. If we know that I squared equals negative 1, we can use that in these next couple steps to tidy this up a bit. So here, 24, negative 6i and negative 40i will be minus 46i. And then you have a positive 10, and like we said, I squared is negative 1, so it'll be times a negative 1. And then in your denominator, 64 minus 4 times I squared. Again, I squared is negative 1. And so now this will become 24 minus 10, which is 14, minus 46i, all over 64 plus 4, which is 68. And here everything is even, so we could divide each value that we see there by 2. And this can simplify to 7 minus 23i over 34. And if we look in our answer choices, that's going to match answer choice C. They split it up, which you can do. Each term individually is over 34. So this is equivalent to saying 7 over 34 minus 23i over 34. And that's our correct answer for number 11. So the key there, memorize I squared equals negative 1, and understand your second concept piece for this is to understand what it means to multiply by the conjugate. Up next, we'll take a look at question 12. So for 12, it says a website uses the formula above to calculate a seller's rating, R, based on the number of favorable reviews, F, and unfavorable reviews, N. Which of the following expresses the number of favorable reviews in terms of the other variables? And here we can see in our answer choices that everything is in terms of F equals. So basically, this is a long-winded way of them asking us to isolate F, to get F by itself. So let's see how we can do that. Now, a lot of times, I see students on this question multiply both sides by that denominator of n plus f, which is great. That is exactly what we want to do. In order to cancel that out, we're multiplying times n plus f on both sides. And so a lot of students will write something like this on their page, and they'll have r times n plus f equals f. And then they look at their answer choices and go, well, I have f by itself, but I don't see anything that says r times n plus f. What's going on? And what's important to note is that when you isolate a variable, in order to do that completely, you have to get every term that has that variable in question to the same side of the equation so that you can factor it out. So let's take a look at what that's going to look like. Here, if you distribute r, you'll have rn plus rf equals f. And again, it looks like f is by itself, but it's really not completely by itself because we still have this other term here, rf, that has an f in it. So we have to take everything that has that variable, everything with an f, and move it to the same side of the equation. So don't forget about this term over here. You'll have rn equals f minus rf. And now that we have everything with an f in it on the same side, we can factor out an f. They both have f in common on that right side of the equation. So if you divide by f, you're left with 1 minus r when you factor out your f. And now we have just one f, which is what we're looking for. So we can divide both sides by 1 minus r to get f completely by itself. And we are left with f equals rn over 1 minus r. And that matches answer choice B on this question. So again, don't be intimidated if at first you try to isolate f and then you get to this step or maybe this one and you don't see an answer choice that matches that. Just remember, everything, including this RF, everything with an F in it needs to be pulled to the same side so that you can factor out. And once you do that, you'll find your answer. We'll take a look at questions 13 through 15.